Alright, so for today's notes, go ahead and go to your title page and record 1.2, intervals and inequalities. Okay, now let's go ahead and go on to the first note page. Today we're going to be talking about intervals and inequalities because this is a good foundation before we start getting back into domain and range again. It's been a while since we've really dived into domain and range. We talked a lot about it in Algebra 1, but I know it's been a while since you've had Algebra 1. Okay, so let's go ahead and get started with this first problem. We are looking at the bounded side. So these are called bounded intervals because they have two endpoints. This first example, we're saying that x has to be between -2 and +3. So x is greater than or equal to -2, but less than or equal to +3. And because this is a less than or equal to sign, we can use closed circles on the endpoints. And then I would shade any number between it, because x could be any number between it. It could be -2, it could be like 0.5, it could be 2.999, it could be 3. Okay, so x could be any single number between -2 and +3. Now let's write this as an interval. So I'm going to bracket -2 and then put a comma, +3, and bracket it. So this is just another way to write it in a different format. And if you want to make a side note here as to why we use the bracket, so we bracket because closed circles. So anytime you have a closed circle or a less than or equal to sign, it's going to be bracketed because it can actually equal those numbers. Let's go on to number 2. So this is an example of a half open interval. X has to be between 1 and 5, so it's greater than 1 but not equal to it, and less than or equal to 5. So since this inequality does not have an equal to sign under it, we cannot do a closed circle. We need to keep it as an open circle. So whenever I go to write this as an interval, I'm going to use a parenthesis around 1 instead of a bracket. And you can make a side note that we do a parenthesis because of the open circle. Moving on to number 3. Alright, so now we're saying x has to be greater than or equal to -4. Let's go ahead and shade that. But less than 0. So this is opposite. I'm starting off with a closed circle, but ending with an open circle. Now if we write this as an interval, I would bracket -4 and put a parenthesis around 0. Now let's move to the other side. So we're going to work with the unbounded intervals. These are called unbounded because they have one endpoint and keep going to infinity, or they don't have any endpoints at all. So in this first example, we're saying x has to be greater than or equal to -3. So I'm going to go ahead and start with one endpoint at -3. And it is closed because it can equal -3. And I'm saying that x has to be greater than or equal to that. So if I want any number greater than -3, what direction should I shade? To the right or to the left? To the right, because I'm shading greater than that. Notice that my arrow is pointing to the right, which should be the exact same shape of the arrow in the inequality. So greater than should be to the right. Alright, whenever I write this as an interval, I'm going to start at -3 and bracket it. And then we're just going to keep going to positive infinity because this line just keeps growing and growing. And anytime you go to infinity, wow, that was a beautiful infinity sign, you're going to put a parenthesis around it because it's never going to stop. It's just going to keep going. So that's why it's called unbounded. All right, now let's look at the next example. So I'm starting off at positive 4, but x cannot equal it, so I need to leave it as an open circle. And then I'm shading everything less than 4. So less than should be to the left, which if you'll notice is the same direction as your less than sign. This one, sometimes kids write backwards. Anytime you have a less than on an unbounded, you actually need to start at negative infinity, because we're always writing these from least to greatest. So any negative number is going to be less than positive 4. So this would be from negative infinity to positive 4, and both would have parentheses around them. All right, last example up here. So I have from negative infinity to positive infinity. So basically the entire number line. I could have any number I wanted, and that would fit this description of this inequality. So if we write this in interval notation, I would just do negative infinity to positive infinity. This is also called all real numbers. Remember this fancy R symbol? And that means the same thing. Okay, let's go to some practice problems. So we want to draw a number line to match the description. It's either going to give you an interval or an inequality, and then you're going to write it in the opposite format. So let's start off with number 1. I have negative 5 to positive 3. So pay very close attention to the brackets or parentheses. So negative 5 is bracketed, so that would be a closed circle. Positive 3 is a parenthesis, so that would have to be an open circle. And then I would shade everything between it. So now let's write this as an inequality. So I'm starting off at negative 5, and it has to be less than or equal to, because of the bracket, x, and then x would be less than or equal to positive 3. Whoops, not equal to. See, I messed up. Just less than positive 3, because it's an open circle. Okay, let's do number 2 together, and then I'm going to let you try number 3, and obviously I messed up on my numbering. My bad. Number 4 on your own for a ticket. So on number 2, we know that we have an endpoint at negative 2, and it's an open circle because it can't equal it. And then I need to shade everything greater than that because its x is greater than negative 2. So we would be shading to the right. Now we're going to write it in interval notation. So I'm starting at negative 2 and then going to positive infinity. Alright, for number 3 and 4, I want you to pause this video, and you're going to try it on your own. And then if you get both of them right, you can get 2 tickets, and if you get one right, you can get 1 ticket. So try your best. Okay, let's go over them together to see what you got. So this first one goes from negative infinity to positive 4. And 4 is bracketed, so I would do a closed circle on 4. And then I would shade everything less than that, because I'm going from negative infinity to positive 4. So this as a inequality would be x is less than or equal to positive 4. Remember that your inequality sign should always face the same direction as your arrow. Alright, for number 4, we are starting at 0 with an open circle, and then ending at positive 4 with a closed circle, and shading everything between. And then as an interval, this would just be 0 with a parenthesis to 4 bracketed. Alright, that's it for the notes. Now you're going to do a fun activity called a snowball activity. And then after that, you're going to get on Google classroom and then click on your assignment. On that assignment, you can copy and paste the inequality signs, and also you can copy and paste the arrows that I made so that you don't have to recreate them yourself. All right, hope you guys have a great day. Talk to you soon. Bye.